So you're going to see questions as such. And next up over here, we are going to cover your trigonometry graphs. So I am aware that certain students at my side, all right, regardless IP or not, they have trouble actually understanding the graphs or forget their graphs and what is the amplitude, what is the period, and how do you calculate the center line, what's not, what forth. Okay, so I hope through this particular revision, all right, it is going to be a little bit clearer for you all. Okay, so let's just do a quick recap in terms of the trigonometric functions and ratios. And in this case over here, all right, these are just certain tips you need to know lah. Take note, this is not learning the content. So you realize over here is just certain pointers that we need to take note. Okay, if you're unsure of your content, I urge you to actually do some quick revision at your side. But otherwise, what happens, feel free to ask along the way. I try my best to help you guys. Okay, so for trigonometric function and ratios, if you have to deal with it, first thing, always tell yourself, always identify the quadrant. In certain questions, all right, they will actually tell you A and B are in the same quadrant, A is in are in different A and B are in different quadrants, what's not, yada yada. Okay, you have to read the question from the condition. So the first pointer, you always have to identify the quadrants. Okay, I'm gonna deviate a little bit in terms of what certain teachers teach you because they may actually tell you to label the triangles with the negative sides. But what I'm gonna say is, all right, if you look at pointer number 3, pointer number 2 over here is just to tell you to draw your right angle triangle. Okay, maybe you all want to write down. This is just to ask you all to draw your right angle triangle. Okay, pointer number 3, this is what I'm going to do a little bit different, all right? When you label your opposite adjacent hypotenuse, all right, the key difference over here I want you to take note is that I want your label to have them to be positive. Why? If you picture and it kind of makes sense to you guys, can the sides of a triangle be negative? No, right? Definitely not. If you can meet a side of a triangle that's negative, you let me know. I'll be more than happy to see who invented that triangle. Okay, maybe possible in the realm of different numbers, but I'm not going to go to that. Okay, what it makes it negative, key point over here, is that it is the quadrant over here, which quadrant it lies in, that determines whether it is positive or negative. Remember that fact. It is not because the triangle has a negative side, therefore negative, even though when you label it's that case, it is the quadrant that determines whether it's positive or negative. So remind yourself that fact. Okay, I'm going to do things a little bit differently, all right? If you happen to have heard your teachers or maybe other tutors at your side that says this, I'm going to do it a bit little differently. Hopefully you get it now. Okay, pointer number 4, all right, when you do ratios, all right, never do sine, cosine, or tangent inverse because you're finding a ratio, you're not finding an angle. Okay, and also over here, there are certain identities that you may need to take note, but honestly, all right, a lot of them say memorize this, but really not. Okay, I purely don't believe in memorizing. You got a formula sheet, use it to you, and in this case, this is the addition formula. Okay, if you guys forget the addition formula, please look the formula booklet at your side. Okay, it is under the formula over there. Okay, sine A plus minus B and cosine A plus minus B. Follow the convention, press your calculator, you are going to get this two down. Okay, all right, and the other one also, you can also use the addition formula as well. How to use, all right. Okay, I'm just going to write for one. You guys can configure the rest. Minus A, I can write it as 0 minus A. Makes sense, right? I mean, A, in this case, the first angle is 0, second angle is A. I'm going to repeat for the rest. Okay, it's not O minus A, it's 0 minus A. Apply the addition formula, and yeah, you get it down. In fact, we are going to cover a bit of addition formula for certain questions in trigonometric functions and ratio, but of course, it's just for this particular notion. You are going to fortify a little bit more when we go through the Trigo session 2, all right? If you've signed up with Teacher Clarence, he will emphasize a little bit more on the different identities to use, especially for proving. Okay, I'm not going to cover that today, all right? That's not the main focus. All right, cool. All right, okay, let me just cover a bit more before I entertain any questions. Now, over here, you see this table and understand that it will be a bit troublesome because you all will memorize. But I urge you all, no need to memorize at all. Why? Okay, what the trick is to do. All right, you key into the calculator. Specifically, let's say if you look at my example over here. If you key into the calculator, make sure your calculator is in this case degrees. If you look at my example written in blue. All right, if you see a very long decimal, all right, square the value. So example, if you key in this, you're going to see a very long decimal. I cannot remember what the decimal is. You are going to see, give me a moment. You are going to see a decimal, all right, cosine 30, 0.866025. It's okay. You square the value, you're going to get 3/4. How to get the exact value? You manually square root this and you realize there's no plus minus because we know acute angles are always positive. All right, so I'm going to give you a while to consolidate the revision. If there's any queries, please feel free to let me know before I start. I'm going to give you maybe about 1 minute or 2 minutes. If you have any queries, please type in the chat, yeah, so that I can get any queries for you guys. All right, if you're all good, drop me a thumbs up. If you need more time, just let me know. Okay, I have a question here. No worries. Okay, so Yuva, do me a favor. Make sure your calculator is in degrees. Okay, gonna give you a while. What happens now, once your calculator is in degrees, I want you to type in cosine 30 in my example. Okay, I think you got it down. Okay, you should be getting down already. Awesome. Then after that, you key in the square. You key in the square, you will get 3/4. What I need you to do to get the exact value, you need to manually square root. Basically, you do the top and bottom. Okay, and in this case over here, maybe to answer Lionel, yes. Similarly, like conjugation inserts, that's right. Okay, one more from Gabriel. The annotated notes will be uploaded into the drive. I will do so. I will do so. All right, I'll make sure I do so, not to worry. Oh, Yadavi. Okay, awesome. Thank you. No problem, no problem. All right, I'll entertain one more query. No problem, Lionel. Any other questions? Pardon me if I'm holding a water bottle at my side, because I don't want to sound too hoarse as I go through this session and be hearing like a loud pitch person over here. All right, okay, seems like there are no other questions. Let's get started on the certain questions. Now, over here, what happens is, if you look at all these particular questions over here, okay, I think I have one more. Okay, give me a moment again. Okay, I'm just gonna send the notes one more time, yeah, because it might get a little bit disruptive in the flow. So I'm just gonna send it one last time. Okay, please make sure you have downloaded and received it at your site. Okay, for convenience sake, the annotated notes will be uploaded at the end, so not to worry at your site. Okay, now I'm just gonna go through in this case 3 particular questions, all right, of conventional style of trigo functions and ratios that you get. And you realize over here it kind of closely links towards certain formulas that we always use. So as mentioned, all right, they will tell you sine A cosine B. So effectively, all right, A and B are in the same quadrant. Okay, so always remember in the same quadrant means the angles are in the same quadrants as well. If the ratios are in the same quadrants, my angles are in the same quadrant. Okay, cool, yeah? Now, this is where I'm going to test you guys before I draw the quadrants. Okay, so sine A is this, all right, which we know sine is positive. All right, and cosine in this case is this value, but in this case, I don't want to know. I want to know which quadrant it is for such questions. Cosine is negative. So if sine is positive, cosine is negative, can you all type in the chat for me which quadrant will these two angles lie in? I want to see how is the progress so far. Type in the chat, please, whether via PM or via in the general chat. All right, type in so that I'm aware. Sine positive, cosine negative. All right, Javier, very nice. Any other responses? Don't get taunted by Javier first. All right, type in your responses. All right, I want to see everyone's response. Okay, thank you, Ivan. Thank you, Ishan. All right, I'll give a bit more. Thank you, Gabriel. Let's see, let's see. Ashi, very nice. Wow, wow, wow. Lionel, very good. Demia, awesome. Okay, so you guys are aware. The first thing to do, all right, you guys have identified the correct quadrants, very good, is to identify, all right, where the angle lies in. So both of them are in the second quadrant. Now, this is where I need you guys to be a little bit careful over here in terms of labeling the triangle. So what I want you to do, all right, we know both of them are in the second quadrant. So over here, let's say I'm drawing for angle A. Gonna do the same thing for B as well. What I actually want you all to do when you guys are labeling your angles and the sides. Yes. So that's a very interesting analogy. Andy steal Terrence cake. So I believe Andy and Terrence's are your teacher's friends. It's a very interesting analogy, all right? But yeah, that's the one. Okay, so over here, all right, once you have listed everything here, label your sides clearly and carefully for the respective angles. And the negative sign, I don't write it there. I write it to know that this is my S quadrant. So when I see the letter S, I only know only sign is positive. So if you see cosine of the angle, if you are labeling, we know cosine is negative or tangent. All right, so I don't like to label triangles that are negative sides because it makes things more confusing. For me lah, but if you prefer, go ahead. This is just my tip. Now, of course, you realize I only have two sides of a triangle. Use the Pythagoras theorem, find my third side over here. All right, I won't waste the time. This is 4, this is 12. All right, I believe you guys know how to apply the Pythagoras theorem over here lah, yeah? Okay, so both are Pythagoras theorem, just apply accordingly. And remember, this is towards forming your ratios. When you are doing a sine of an angle, all right, we are usually relating to a basic angle over here. Okay, once you guys get this down, you realize this formula has been here for the longest time ever. All right, why? Okay, because it's just waiting for me to apply. All right, so what happens? I have cosine A minus B. All right, just apply the correct one accordingly. Cosine is a little bit tricky. All right, because minus means plus. It's different from sine. So please, if you forget, all right, make sure you refer to the formula sheet, play safe. All right, so I'm gonna have cosine of A, cosine of B, plus sine of A, sine of B. So usually, trigo functions, the ratio questions are as such. Once you get it down, cosine of A, look at the respective angle. Cosine is negative. Cosine is adjacent. Sorry for that. Cosine is, my God, sorry for that. Cosine is adjacent over hypotenuse. You are done. Cosine B. Now, cosine B is also negative, but please take note, you're looking at this triangle now. Don't use the wrong triangle. So, negative 5 over 13. Okay, plus sine is positive. All right, this one, if you actually forget, is given in the question. Sine of B is positive, so that's why I don't like to label the sides of the triangle to be negative. Sine of B, 12 over 13. Once you are over here, it's really from here, take your calculator and press. I don't want to waste too much time over here. 56 over 65. Moral of the story for part 1 is that you need to identify the angles, which quadrants they lie in. After that, Pythagoras theorem. Then you apply your special identities. Trigo, not the A plus B square, that one. That one will be mainly for your section 2 when you prove stuff. This one, your trigo identities, just apply accordingly. Okay, this should be rather straightforward, but I'm gonna stop here for a short while to get people and entertain any questions that comes in. Yeah, I'll give you a while to consolidate. Any questions, feel free to type and ask, yeah? Okay, very silent chat means this question, no kick. Okay, awesome. Now, the other question, if you look at part 2, for those who have the material, you may realize when you look at half angle, walao, half angle, so troublesome. Okay, but you realize to half the angle is really noting that one of the angles is twice of each other. So I'm looking at these 3 formulas over here. All right, to sort of really help us. Okay, so, okay, over here, these are the three things that you will actually need to take note, all right, so that we can find. Now, I want to find, in this case, cosine A over 2. So, while I am labeling these equations, because I want to ask you all a question, let's say this equation is equation A, this equation is equation B, this equation is equation C. Now, disclaimer, all three equations then definitely be used. But of course, you have sacrificed your time here, so I'm going to ask this question in a very specific manner. Which equation will be the one or the fastest one to allow me to get to the answer quickly? All right, type in the chat A, B, or C. Why is it not cosine 4 over 5? Take note, cosine is negative at that quadrant. Both of them are in the same quadrant, Kaden. Second quadrant, yeah? That's why it's for cosine negative. Anyway, there shouldn't be a cosine that is negative 4 over 5. Okay, cosine is negative. Both of them are in the same quadrant. Okay, I hope I've answered your question. Okay, for the rest, okay, I have one answer. Noble has one answer. Kaden, if you have gotten it down, let me know. Okay, good, good, good. Okay, very nice. Okay, okay. I think most of you got it down lah. Awesome. A or C, possible, possible. All of them are okay. I'm just saying which is more effective. Okay, I think I've got most of your responses. Very good, all right? Answer for me with the most effective way is, all right? Yes, they can solve all equations correctly, Lionel, but my question here is, which one helps us get to the step fastest? I'm not here to allow you to, I'm not here to ask you to get the correct answer. I want you here to get to the correct answer the fastest. That's why you're here. Because if you can get the correct answer, I can ask you, I can just send the answer scheme, you're already at home. There's no point. I want you all to make sure you all get the answer the fastest and accurate. Okay, so in this case, my final answer, all right, to solve it more effectively is actually A lah. C over here also possible. Okay, I think you all got this down because if you all look at it at the top, you realize I have sine of A cosine of B, and from there I can find cosine of A and sine of B. Okay, either or. But how we place the formulas is very important over here. Now take note. Now that we know that we are going to use this, here comes the second question. I love to give you kind of questions so you all see whether you can understand. Over here, A over 2, the placement of A over 2 is very important, yeah? Do I put it here or do I put it here? Okay, give me or type in the numbers in the chat. This is choice number 1. This is choice number 2. All right, this is where I want to get your answers down. Choice number 1 or choice number 2? How to find out which is the most effective? That's where I'm going to go to now. Okay, very nice. Nobel, Lionel, awesome, awesome. The other responses? Okay, I have a stream of twos. Ivan, Ashif. Okay, I think you all got it down. Okay, now, why all of them say 2, if you may realize? Okay, let me see. 2, 2. All right, now, why all of you all say 2? Okay, you want to make use of what you have. As I mentioned, you have cosine, right? So, if I have option 2 here, if I put 2 cosine square, this is what we want to find. And the reason or to answer, sorry, let me get the name right. Yadavi, accordingly, is to try to see now which one over here allows me to solve it more effectively. To solve it more effectively, I don't want to find this again. I don't want to find this again too, because that is what I want to find. If I'm able to just plug the value, which comes in quite some practice, but the guideline is, when you form the equation, how to find its most effective, if I can just plug the value, cosine A, which is negative 4 over 5, I am merely just solving, sorry for that, I am merely just solving a pseudo-quadratic, like a fake quadratic equation with one variable. So what I can do, all right, I'm gonna say, all right, let's shift my 1 to the right. You know the boring stuff right now. Okay, so I want over 5. Then I have cosine squared to a over 2 to be 1 over 10. Okay, and then this one, maybe they want the exact form. And you realize over here comes the question. Because, all right, I'm just going to draw the arrow down first. Because the thing is, you all have learned in Sec 2. When you're square root, all right, when you're square root, there's going to be a plus minus. And in this case, this question only allows one answer. Now, here comes my question again. Haha, I like to ask this. Which one is correct? Equation 1? Equation 2? Type in the chat. I want to see what are your responses. Okay, I have a stream of... Wait, let me see. I have quite some... Oh, okay. Very interesting. Okay. Please read my equation carefully. Okay. Okay. Learning pointer here. Very good. Okay. I think some of y'all see majority wins. Then y'all type. Then I think some of y'all, I think based on what I'm saying, you guys know what I'm going to. Okay. So majority of y'all said 2, but I am going to tell you, 2 is not the correct one. This is the correct one. Now, why? Let's check. Because we know, to know what is A over 2, we backtrack. They tell you A and B are same quadrants, right? A is in the second quadrant. For it to be an angle in the second quadrant, how big must it be? Okay, I'm going to write it down. So before your answer, our teacher always gives 2 as the answer. Not always true. Second quadrant is always going to be... But I'm not working with A now. I'm working with cosine of A. This is always acute. So if it's always acute, ching ching. So we know this is not correct because it cannot be negative. So we reject. And okay, I know some schools will penalize if you don't rationalize. So good to rationalize. This is my answer. So always look back at the question and know, because in the same quadrant, how wide your angle is. Okay, so don't always assume it's negative because A is negative. Always relate back. Okay, so I'm going to stop here for a short while. Okay, I'm going to entertain any questions if needed before I move on to the next 2. Okay, just going to wait for a few seconds to take note. Okay, I have one question. The negative part again. This is obtuse, right? We know for obtuse angles, cosine is negative. But I'm not looking for A. I'm looking for cosine A over 2. So A over 2, if you look at the range, 45 to 90 is an acute angle, right? Cosine of an acute angle, is it positive or negative? So I hope you got the answer from there, and that's why we reject. If I use the rejected one, you will lose a mark because you have actually used the wrong one. So be very careful. No problem. Lionel, okay? You won't lose everything. You will just lose like that mark. So please be careful. Okay, Ken, any other questions? Feel free to type in the chat. I'll be more than happy to ask entertain any queries. And in fact, I have catered enough time for every single question here. I hope so. Not I hope. I will. So not to worry. Okay, can Okay, looks good. Now, okay, once you get the flow of this type of question, the rest of it will be the same way. Okay, wait. Give me a moment. If I use the half angle formula but it is not taught, will I get penalized? Your half angle is a double angle. So it is in your formula sheet. So regardless, you'll not get penalized. Your half angle is your double angle, Gabriel. So confirm won't get penalized. If you have learned double angle, it is your half angle. Because to use the half angle, you have to know your double angle. Because they are just directly related. Yeah, no worries, no worries. It's okay. Awesome. Good, good, good. Good to clarify, yeah? Please, 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 please. So that I know where your queries are. Awesome. Now, the other question, once you look at it, you realize, isn't this like the same thing that I've been working all the while? I need to know which angle my quadrant is. In this case, they're very nice, ma. Okay, this time they're very nice. This question, A is cute. Done deal. You realize, sure, why do you need this? I thought the answer is just, maybe I take the cosine inverse over here, then I find the angle A. But take note, first thing they restrict you for this is, you take the cosine inverse of 1/3, you are not going to get the exact value. Okay, you're not going to get the exact value. So that is where you ask yourself, if you look at the double angle and the exact value there, please refer to your formula sheet. Use them lah. Okay. Life is already very tough lah. I think I saw some of my regular students there. They have heard me use this phrase for the longest time, so I'm gonna just use it here again. Life is already very tough lah. So don't let me make your life tougher. Just try to see what formulas you can use, and especially over here, cosine 2a, refer to it. Again, same question over here. Now, you all see the question first. I'm not gonna write down anything. Same question. I want this to be two-way. This is, I use alphabets this time. Equation A. Again, all equations are okay. Just tell yourself in this case, what do I want to find and what is given there already? A, B, and C, which one will be the most effective? Keyword, most effective. What are the answers? A, B, or C? Okay, thank you, Ivan. Again, all can be used. I want to check which one's the most effective. Okay, Javier, thank you. Lionel, thank you. All right, keep on the responses. Again, not majority doesn't win. Okay, you can have other answers also. Okay, Ashif, thank you. Any other responses? Um, can. Can, no problem. I already say already. You want to use A, you want to use B, you want to use C, can. It's just which one is most effective lah. I'm looking for most effective. Okay. But thank you for your answers, Kaden and Lionel. C's, B's, okay. Again, if you use A also correct. You use B also correct. You use C also correct. What I want you all to do is which one is the most effective. Okay, I'm gonna write here big keyword. I'm looking for the most effective. Okay, if I want you all to find just the correct answers, I can just pass you all the answer scheme. I leave the chat already. Alright, most effective here. Okay, thank you for the responses, Damien and Lloyd. So answer here is actually, for it to be effective, B. Now, I foresee that for those who actually answer maybe A, maybe C, alright, might have actually mistaken what cosecant is. Okay, so we call cosecant. What's the end goal? I want to actually find, if I rephrase the question, what is 1 over sine A? So 1 over sine A, which one closely related? This one, ma? You can use C also, but that means we are actually needing to actually evaluate what cosine A is, which we cannot really find it here. Take note, cosine A is not 1 over 6. I know what some of you are thinking. This doesn't mean this. Of course, you also can use the longer way to find cosine A as well, but it's a bit long. We want to try to keep it short. Okay, so how does that work if you write B? First things first, we know cosine 2A is equals to 1 minus 2 sine A. Take note, I want 1 over, but it's okay. If you think about it, we find sine A, we just take the reciprocal. 1/3. 1 minus of this. This is just a one variable pseudo quadratic equation. Bring over minus law. 2 sine square A equals to 2 over 3. Okay, sine square A is equals to 1 over 3. I think this one is a bit better, but I still want to test you all again. Sine A, I square root got 1 over root 3 or This one. But I can only have one answer for sine A. Again, this is equation A, equation 1. This is equation 2, which is the correct one based on the question. Type in the chat, come. So that it is so that I want to get your brains thinking. Thank you, Kaden. This should be okay. Okay, good, good, good. I see a string of ones. Very nice. Boom, boom, boom. All the one come out. Sweet lah. Damien, Javier, Lloyd, Ivan, Ashif, Lionel. Very good. Okay. I think this one quite clear. They say A is acute lah. Thank you, Yushen. Awesome. So once you got it down, you realize, okay. Don't be too happy. Don't. Wow, yes, I got this. This final goal is. Okay, so cosecant is take the reciprocal. Reciprocal means you either flip the thing, or of course, you just take the 1 over basically 1 dividing by this number here equals to root 3. Okay, alright, so just make sure again, definitely I feel you are able to get the steps down, know what equation to use, but which one is most effective? If you use the rejected one to do the cosec stuff, yes, error carry forward will be given lah. I would say yes, but don't risk it. Maybe error carry forward, depending how strict your teacher is lah. So just be careful. You will get error carry forward. But most schools I know, once the first one wrong, the second one is wrong because it is stated clearly that A is acute. Okay? Any other questions? Yeah, correct. Provide your cosec stuff is correct lah. Yes, definitely. Need to reject too, right? Yes, thank you very much. Wow, very sharp, Damien. Awesome. So I forgot to write reject. Yes, thank you for helping me, yeah? Very sharp, love it. Any other questions? Okay, can Awesome, awesome. Now let's move on quickly to the last one. Okay, so over here, yes, they give it in a little bit of a weird way. All the ratios, all very different one. Then we realize, walao, what is this asking about? They give sine, they give tangent, then value of cosine for x. Why so troublesome? Now, always remember, regardless of how weird the phrasing is, for such question, what's the first goal? Find out where the angle lies in which quadrant, right? So in this case, for this type of condition, we don't have to know what the values are first. Sine x equals to negative. I don't care the 4 over 5. Yes, you draw your quadrants first, making sure that, very careful, it's not the first quadrant. Don't, I know you're very eager to answer. Thank you very much, but it's not the first quadrant. Sine negative already tells me it is not in the first quadrant. Tangent x more than 0 is tangent positive. See, I think you're very sharp, very hyper already. So tangent positive, sine negative, my angle is in the third quadrant. Thank you, Damien. Okay, and for the rest, I hope you know, this is to be familiar with your quadrants. Do we draw the quadrants first for this type of question? Oh, sorry for interpreting your questions. Yes. Always draw. So that is clear for you, ma. You don't have to think in your head, visualize. When you look at graphs, you need to visualize more already. So just draw. I rather you waste a few seconds. Draw these arrows. Okay, let me change the color. Draw these arrows over here. Sorry, this is not straight. Okay, draw these arrows here. Knowing that this is my third quadrant. So in this case, randomly lah. And my angle is this way. Take note, the whole thing goes through where my basic angle is this one. Then you label. Sine is opposite hypotenuse. Label big, this is the T. So anything is negative. You do Pythagoras theorem. This is 3. Okay, and then maybe I label it a bit clearer for those who are unaware. This is my basic angle. Basic angle. Yeah, so always label this first before you proceed to the question. Not saying you will get the mark for this, but at least you draw, you are giving yourself a chance to actually think, I know how to proceed. Okay, so for this one, This question a little bit hard. There is no right or wrong for this. Okay, I do have a working over there. The school actually provides another working, but for this case, I do actually have to agree for the case, the school's answer scheme is a bit better. But I want to actually tell you guys there are multiple ways to solve this. Okay, so I am actually going to write down first. Same stuff lah. I think you guys know what's coming. I think no, let's not write 8 because the angle there is A already. Equation 1. Equation 2. Equation 3. Which equation is the most effective for solving this? Okay, and I mean based on my questions here, my working here, you see later, I don't think you guys will find it effective, but I want to see how you guys are thinking about this. Which one is most effective? Okay, nice. Any other answers? Okay, okay. All right, Clarine, thank you. Awesome, Lionel, thank you. Kaden, thank you. Any other responses? Okay, all right, awesome. Thank you for the participation. So if you take a close look, okay, most of your answer 2. Actually, 2 is what the answer schemes provide. So I'll briefly write down what the schools mentioned first. Actually, you know what? Should I write down both? You know what? I will write down what you all say. Okay, then I'll calculate. Then at the end of the class, when I send the answer scheme, all right, I'll send the answer scheme into the chat so you all download before you all leave. I will actually show you the working to how I solve for 1. Okay, so for those who are actually present live, you guys are in luck because you actually get to see both workings. Okay, so how they solve 2. Now, we know cosine 4x. I want to break it down further. So the angle has to be divided by 2 because ultimately I want to solve for x. So follow your guys' thought process. Cosine 4x is 1 minus 2 sine square 2x. Now, think some may ask, still got 2 sine square 2x. How? Okay, for those who are unaware, I can. Okay, this one I didn't write the formula down because I didn't expect the answer to be 2, but it's okay, doesn't matter. Sine 2x we call, this is 2 sine x cosine x square, where this is the identity. The square is here. Then after that, you guys know the drill. Okay, of course, write down my numbers first. 2 square is 4, 4, 8. I have 8 sine x cosine of x. Pump in the numbers accordingly. All right, it's negative 4 over 5. Cosine, negative 3 over 5. Punch in, type your calculator, tell yourself, final answer is this. Okay, so either you approach it with 2, it will be fine. 1 is also fine. In fact, if you want to do 3, is also fine, but you might torture yourself with that. So I urge you not. Why is the 1 not multiplied by 2 as well? Take note, my double angle goes with the angle that is affected only. Okay, Kaden. So if I'm saying cosine 4x, it is broken down. This is where you have to be careful. 2x. So your A here in this question will be 2x. Take note, only the angle gets affected. So the constants there will not get affected. A is the one that's getting affected over here. You don't get the green bracket. Sine 2x is 2 sine x cosine x. Yadabi. Sine 2x is 2 sine x cosine x. That is in the formula sheet. So if I square this whole thing here, this whole thing here gets squared. That is why your green brackets are like this. I hope it's a little bit clearer here. No problem. Any other questions? No problem, Kaden. Okay, any other questions? I'll wait for a few more seconds before we proceed to graphs already. Okay, just wait. Lucky I wait for a few more seconds. Wait, let's see. Okay. Okay, your one, not related lah, but I'll just do a quick one. I'll just do a quick one. If you mean, the set is this, I answer you after this class, can? Alright, because I don't really wish to drag. So, technically, alright, I'll just do a quick one for your question. The set contains an empty set. Technically, it contains nothing. So, your set is empty, so it should be an empty set. Okay, I'll just stop it here lah. I hope it makes sense. Because empty set is nothing, it contains nothing, so it's an empty set. No problem. Okay, sorry for digressing a little. All right. Okay, any other questions for functions and ratios? Okay, no, okay, all good. Okay, awesome. Hopefully you guys are a bit refreshed on functions and ratios. Mainly the type of questions are in this similar manner. You will need to use your correct trigo identities to solve this kind of questions lah. Okay, now let's proceed. Graphs. Do a quick recap first. Firstly, all right, let's recap the very good old sine graph. All right, common shape. All right, you have to know your general shape first. It's going to be up, down, up, like an upside down mountain with one hump at the top and one hump at the bottom. And what are all these things here? All right, we call the number A is your amplitude. This B over here will affect your period. Now, let's recall first, normally your period will be 360, but because of the value of B, it will scale your period of 360 or in radians 2 pi. So please be very careful. The one I'm highlighting in green is your normal period of sine. Okay, then C over here is basically what we call your starting point, equilibrium point, or most of you all might be familiar with this term here called the center line. Okay, so in this case over here, you realize it starts at 0 in the middle, so my center line is 0. So maximum value is really at the top. You need to consider how much the center line is before you shift up. Minimum point is where your center line is before you shift up or down, depending on where your center line is. Okay, once you actually get this down, for cosine, the only different thing is really the shape. I am really just gonna copy whatever I highlight and just gonna translate it here. It's the same thing. The only thing you need to take note is your shape over here is basically Mount Everest tilted down. So it's an inverted Mount Everest. I don't know how tall Mount Everest is lah, but I assume everyone should know Mount Everest as a mountain. If you don't, I apologize, but yeah, basically it's a mountain flipped upside down. Center line, everything is the same. All right, the notion of how your period gets affected by the value of C, same thing here. Okay, once you get this down, okay, just do a quick recap over here. Okay, last part of recap already before we go to questions. Tangent over here, it does have a center line, but very tested as well because you know your tangent graph just goes all the way up and down. So it doesn't really have any significance if you shift up and down accordingly. But it's still good to know the period of a tangent. All right, which in this case, be very careful. It's not 360, it's 180. Okay, and because your tangent has this thing called asymptotes. Okay, for those who are wondering what or hearing this for the first time, what are asymptotes? It's basically imaginary lines that your graph will never touch at all. So it just goes on and on and on and on and on and on and on, but it will never touch the line. That's why dotted. It will touch, it's solid. Okay, and because if your period changes, your asymptote will changes as well, but the good news is the scaling will change also as well. Okay, so I'll give you a while to consolidate this. I've only given in degrees. Radians also the same thing. Not much difference over here. Okay, cool. Yeah, so give you a while to consolidate first. Okay, before I move on to do a quick quiz on maybe like quick checking in to see that you know how to find the periods using tangents. Because if you can do for tangents, sine, cosine works the same way. Okay? Alright, come. Can anybody tell me what is the period of tangent to x? Type in the chat. I think for simplicity, you all give me degrees lah. Radians a bit hard to type in chat. Tangent to x, what is the period in degrees? I want to see whether you guys are aware. Okay, thank you. Thank you, Ivan. Thank you, Damia. Okay, so I think some of you are shy. Want to PM me also can. Okay, very good. Thank you, Gabriel. Thank you, Lionel. Okay, you guys got it down. So we are just dividing by the constant 2. Okay, so really just in this case, 180 divided by 2, that's 90. All right, so I'm just going to display it here. Or in this case, in radians will be pi by 2. Okay, as such, all right, take note your asymptotes 90 and 270 will get affected as well. Okay, the ones in bracket is not multiply, it's just saying the equivalent of it in degrees. Okay, so I'm gonna give you some time to write it down before I move on to the next one. Okay, so take this time to recap, okay, because it is gonna be very crucial for such questions. Okay, tangent half x, what is my period? Type in the chat, please, so that I can check. For those who are shy, now is the time to actually ask me, or you can PM me so that like in the chat personally, so that you guys can actually not let other people see your responses if you're shy. All right. Okay, I see a lot of 360. Thank you, Ivan, Damia, Clarine, Lionel. Very good. Yeah, 180 divided by half, which is 2 pi. Okay, same thing. Your asymptotes will get affected as well. Okay, seems like you guys are getting it already. Awesome, awesome. Last one. 2 tangent 1/3 x. Tell me my period. Just type it out, okay? I want you to get familiarized. Thank you, Damia. Thank you, Ivan. Thank you, Lloyd. Thank you, Lionel. Clarine. Awesome, awesome. All right, any other responses? Very good, Javier. Thank you. Nice, nice, nice. Okay, this is gonna give me, all right, 540. Very nice. Okay, thank you for the responses. Or in this case, 3 pi. Okay, 180 times 3, pi times over 1/3. Okay, then your asymptotes will get affected as well. Okay, so remember when you're finding period, which is not so common for tangents, but for sine and cosine, know the process over here, okay, because this will be 3 marks for you to get. Okay, I guarantee you this is the 3 marks for you to get, especially period. You can, all right, I have a question. Period, yes. Answer key. Okay. For the thing, answer key. I will actually upload it in the Google Drive if you're not able to get it, so not to worry. All right. I don't think I want to share the answer key now because if I share now, everyone will just out. So sorry for that. I will share in the Google Drive when I upload it down. Yeah, so not to worry. All right. No problem. Okay, the rest. Any other questions? Awesome. Now, I'll just have 4 questions for graphs in particular, and I would say it's a little bit of variation as we go along. Okay, it's a little bit of a variation as we go along. All right. So the first one will come in, it is going to be asking you to just state the period and amplitude of both graphs accordingly. Okay, and especially for period for A, just be very careful. All right, so for fx, first thing, we need to know what is the period of a cosine graph. So we know it's going to be, all right, since you guys got it down already, 360 divided by half. All right, this is 720. Amplitude, okay, there's no number over there, so it is going to be 1. Please do not write 4. 4 is my center line. Okay, please do not write 4. Okay, I might have another question coming. Sure, can I write 4 pi? Can, no problem. You want to write 4 pi? Possible. Okay, but why do I want to use pi or degrees? Part C lah. Part C prompt me to write degrees. So I write in degrees. But if I write radian, no fault. Okay? Now, for B, sine no change. So I hope you all realize the actual period is 360. But now, this one, I want to see whether you guys are aware. What is the amplitude for GX? Write in the chat. What is the amplitude of GX? Okay, I have one answer. Okay, Verin, Wei En, very good. Lucky I asked this question. Okay, very good. Thank you very much. Awesome, awesome. Nice, nice, nice. Okay, thank you, Kaden. Thank you for participation. All right, so that I'm aware of the certain mistakes they all may make. Thank you, Wei En. Thank you, Lionel. Thank you, Kaden. So, thank you, Damia. So, I have a mixture of -2 and 2. Okay, so now, final answer. Your amplitude must be positive. In this case, answer is 2. Why? We call amplitude is basically the distance from your center line to the top or the bottom. Can distance be negative? So that's your answer to your question, Lionel. Can distance be negative? Very good, Kevin. No, so therefore amplitudes are always positive. You can write that note down if you want to. Thank you for sharing. I can write it down for everyone. It is going to be always positive. Always positive. Thank you, thank you. I love this collaboration here. I'm loving it. Yes. So see, help each other. Then you all learn together. That's what I love. Okay, now, first style of question. Once you know the period, once you know the amplitude, the next thing they'll ask you to do is to sketch both of them on the same axis. This is the first variation. So what I like to do, you realize, right? Then you may see, why you draw all these dotted lines? The thing is, why I want to draw them is because these lines over here, 0 to 360, I draw them because they allow me to segment, let's say my period. Okay, let's say I'm drawing GX first, the normal graph. It allows me to segment nicely so that I'm able to trace it accurately as well. So GX, I'm sketching for -2 sine X, right? What I like to do, all right, of course, I have to trace the maximum and minimum point of the graph first. So let's say my maximum is 2. Minimum is -2. Okay, what I love to do, all right, is I first take note what is -2x. So you can actually, if you forgot the shape of the graph, that negative means my shape flip, key in the calculator, what is sine 0, sine 90, sine 180, sine 270, sine 360. Basically for GX lah. Key in your calculator if you really forget the shape. But if you do, all right, one thing, additional thing I like to do also is to draw 2 horizontal lines at the maximum and the minimum. Okay, sorry for that. Okay. Oh, it erases everything. Oh no. Okay. Let me draw. Let me use a ruler to draw 2 lines like this. Can I use okay, let me use purple. 2 lines like this, one at the top, one at the bottom. Alright, so that I am able to properly plot sine 0. Let's say when you type your calculator, you really forget the shape. Sine 0, 0. Then sine 0, 0 over here. Then next one, sine 90 is 1. 1 times -2, -2. 0. 270, sine 270, -1. -2 times -1, 2. Once you are done, it's really tracing, making sure your shape like a semicircle, like a quadrant. Okay, sorry, it's a bit curved. Up here. So with these dotted lines, it allows us to sketch the curve a little bit better. I'm not saying it's a foolproof way, but with these lines there, it's allowing us to guide it a little bit better. to actually sketch out the whole shape of the graph. Okay, and noting also for 4 plus cosine, take note this one a bit different. The period is 270, sorry, 720. So for this graph, this one I want to ask. How many of a period am I sketching for fx? Type in the chat before I draw. Okay, I'll draw the center line first. Center line we know is 4. How many period of a graph am I drawing for fx? Okay, thank you for answer, Javier. Okay, so what I mean by period is how many cycles am I drawing? Okay, thank you, Kaden, for your answer. Okay, let's see. Now you will answer. Okay, good, good, good. Awesome, awesome. All right. Okay, Wei En, thank you for answer. Wei En, thank you for answer. Lionel, thank you, thank you. Okay, so it's actually half a cycle. So why? One cycle over here is 720. They want 360. How do I scale it? Divide by 2. So that's how you know it from here. So please take note on how many cycles you need to draw. But again, answer wrongly, it's fine. I rather you answer wrong now compared to doing exam. Okay, so over here, this is 3. This is 5. What I like to do, I like to scale with the lines here. So over here, use the rulers. That is provided. Okay, give me a moment. I know the silence a bit awkward, but sometimes silence is also a good way for you to absorb. Let me just draw a line. Yay. Yeah. Okay, so once you have this down, how do you draw half a cycle? Picture, we need to know how a cosine curve looks like. So a cosine curve is an upside down mountain cut into half. So basically, it's like a camel hump cut into half. Okay, that sounds a little bit disgusting, but you get what I mean. If you cannot remember the shape, all right, just pump in your calculator to find the relevant values. Yes, I have a question. B value, which is half. Yeah, you can take that as well. Take that value as well, half. But it kind of depends. Okay, it depends. Okay. So good question here, Wei En. It depends whether the range here is up to that point. Because right now it is half because I'm scaling it from 360. What if I am asking you to sketch from 540? Is it half? So think about it. So that's why I want you to compare with what you are required to draw. It may not be 0 to 360 all the time. Which if you realize in the later questions, I have it to 180, I have it to... Yeah, I have it to 180. I have to 2 pi over 3. So it is not always the value of B. So it's always good to check. So always good to check. But thank you for asking this question. At least now we know you don't just copy and paste the value. Okay, Ken? Okay, back to the question. So draw half a cycle. Key in the values, top is 5. Wei En, I hope I've answered your question, yeah? Over here, over here. So it's half a cycle. So I have this. Wait. Okay, sorry, it's a bit crooked. Let me draw a bit better. Okay. Okay, so this is my fx. So over here, you realize what I like to do for graphs. I like to draw these particular vertical lines to dissect my shape. Okay, regardless whether into 4 parts or maybe for this into 2 parts so that I can see the shape clearer. It allows me to sketch the graphs a bit more beautifully. Okay, so I'm going to stop here a while for this question. Let me know if there are any queries before I move on. Okay, yes. How do you find the coordinates for fx? Type in the calculator. You try when x is equals to 0, cosine of 0 is 1, 4 plus 1, 5. Cosine 90, maybe that one doesn't give you a very good value. You skip first. Cosine 180, it gives you cosine 90. Cosine 90 is 0. 4 plus 0 is 4. You press your calculator to find out good values and know that when you draw the shape, it should curve in. I hope that works for you, Yadavi. Y equals to fx graph again? No problem. Okay, because what happens? We are drawing half a cycle. Ma. Full cycle, we know for cosine, it's this way. Half a cycle, at the end point, what happens? We are only taking this shape. So through this graph, we want to draw half a curve. So it's this way. If you're not able to remember, just plot good points that give you good numbers. So in this case, 0 gives you at 5 because cosine 0 is 1. 4 plus 1 is 5. If you key in 90, you get cosine 45. Cosine 45 is root 2 over 2. It will give you a decimal. That's not good. We don't want that. Cosine 180, you key in your calculator, is cosine 90. Cosine 90 is 0. 4 plus 0 is 4. That's another point. So you get my idea, like Damien. To actually plot in points and making sure you get nice values. Yes, because this is the graph you need to draw. Correct. Because fx is this. Yeah, it's from the question. Can? Okay. Can because that's the graph law, so that's why. Okay, let me draw this weird drawing. Whee! Okay, let me drink a bit of water. Any other? I'll wait for a few more seconds for any other questions before I move on. Okay, looks good. Let's move on. Now, again, this is the marking scheme over here that we roughly check before I move on. It basically tells you your graph must be correct, basically the shape. Second graph, they check for you, okay, basically the period. Third one also basically your period and the shape of the graph as well. So the marking scheme is roughly like that. Okay, so feel free to look through as well over here as such. Now, typical question, just that for this one, there's an add-on. I'm going to go through for part C later. Part C later for this question, I would say will be rather confusing for you guys. Okay? Now, first one, amplitude, this one no issues because there's no negative sign. So we know amplitude is just copy and paste the number. This one, I know you all do best. Now, period over here, what is my period going to be? You just give me in degrees, okay? Because I know it's a hassle to type in radians. What is the period? I want to test. I want to see whether you guys are still with me. What's the period? This one I will constantly test you all. Okay, I have one answer. Very good. Thank you, Javier. Any other answers? What is the period? What happened to the rest? Uh-huh. Okay. Thank you for your response, Damia. Okay. Thank you for the response, Gabriel. Okay. Okay. Thank you for the response, Lionel. Kaden. Okay. Wei En. Very good. Okay. Now I'm going to display the answer. Final answer is sine. What's the original period? 360, right? What's the constant here? 3. So 360 divided by 3. I think it's either some of your mental sum give me the wrong answer, but I think you all got the idea lah. For this question, I'll answer in radians because question give me radians lah. But if you actually give me this one or this one, both are accepted. Okay, so don't get scared. Both are accepted. Okay, so just take note. Okay, don't because you're at 120, then I don't know, maybe sometimes you're hyper. This question came out for your WA. And I know y'all, when y'all are very, very, very excited, sometimes y'all discuss the answers. Y'all say, what's the period? Oh, 120. I write 2 pi by 3. How? Cannot. It's okay. Both of them are the same. Okay, so just take note. Question, again, now over here, if you take a close look, I kind of break it down into 3 parts. There's a reason why. Based on the period, how many cycles do I draw for this one here. Come, type in the chat, how many cycles? Period is 2 pi by 3. I'm drawing up to pi. This is a bit of a harder question. Not harder question, a bit of a more careful thing to take note. How many periods do I draw? Okay, so I'll write a reminder. Sometimes if I'm not sure, 1 period we know is 2 pi by 3. So 0 to pi, how many periods do I draw? All right, thank you for answer, Javier. Close, but take note, we do not just take the number and do the reciprocal. All right, give you another try. I give you a hint already. 1 period is this. They asked me to draw to pi. Close, but it's not 2-third cycle. Don't just copy and paste the number and ignore the pi. That doesn't work. Okay, Ivan, thank you. Okay, Kaylan, thank you. Okay, one of the answers is correct. Okay, now 2 of the answers is correct. Okay, I think once you get it down, you know the idea already. Okay, this is the period of this curve, right? Thank you for answer, Kaylan. So I want to draw up to pi. How do I scale this? Times 3/2 ma? So to know how many periods to draw, I need to draw 3/2 of a period, which is 1.5 cycles. So you actually, one tip maybe I can give you guys is you need to know one period of the original curve is how much first. Then when you want to know how many cycles to draw, you compare it with the scale over here. Specifically, maybe the endpoint. Because the endpoint tells you how many you need to draw before you reach the end. So the endpoint tells you, oh, you need to draw until pi. 2 pi over 3. Okay, but I need to draw pi. What's the scaling? How many periods I need to do? This one simple math, times 3/2. Therefore, 1.5. Okay, from here, we know one cycle is up to 2/3. So again, another general note is to break down your curves. Okay, into 2 here and into 2 here. Because we know your curves are symmetric about these points. Forgive me, it is not that symmetrical, but you get the idea. Okay, then afterwards, because 1.5, that half more is also symmetrical at that part. So I will need to break it down even more and draw it this way. Okay, I know in the end when I draw, your curve will look a little bit weird, but the main idea is this. I want to break my curve down so that it is easier to draw. Have vertical lines. Then what I like to do is from here, before I draw, I like to note 2 things. One, my center line. So my center line, wait, which I draw? Okay, here. 2, after the center line, where is the amplitude? Amplitude 2, 1 plus 2 up is 3. 1 plus 1 minus 2 down, minus 1. After that, 1.5 cycles. So how it works is, again, vertical line, horizontal line, sorry. Okay, and then I will also duplicate horizontal lines, or basically, I mean you all cannot duplicate, but I'll draw horizontal lines at the top as well. So that when I draw one cycle, I'm able to plot the points this way. Okay, let me plot with this one. Forgive me again if the shape doesn't look nice. And then I know half, so it's this way. Where did the 1 come from? The 1 came from here, center line. Okay, so back to this question. I'm just gonna sketch. Okay, so just trace lah. This one is really just note how you trace properly. Over here. And down. Okay, how they look at the marks? If you look down, correct number of cycles, correct shape, correct critical stuff lah. So this one, top and bottom, must be correct. Okay, then of course, I'm not too sure how particular teachers are. Remember to label your graphs. So I have got y equals to 2x3 sine 3x plus 1. Label lah, this one is just label. Okay, so I think this one, I have gone through it quite a bit already. It's more or less on how you consolidate. Why did I split out into more sections? Take note for here. This section here that I give you is for one cycle. To draw up a little bit more for another half a cycle, I split it up more because we know half a cycle is this. It is split with one other line. So I'm just duplicating it for the other half. Just take note, your normal splitting I did is for one. No problem. Okay, any other questions before I go on to the typical question that is shown here? You can, okay, now, part C. By drawing a suitable straight line. Now, this is a very, very, very common variant of a question besides asking you to draw a graph. Out of nowhere, they will ask you to draw a line on the sketch. When you see this, what it means is basically from your question here, because what you are picturing determine the number of solutions, right? They are saying, oh, let's say if you solve this, but I don't want you to solve this. I want you to see how you can actually say what it means to solve this related to this graph you draw. So what they want you to do is this process, okay? Hear me out, This one a bit hard to prompt, so hear me out. What they want you to do is to say and force out a 2 sine 3x plus 1 in your equation. I know this is the confusing part that most of you all get it out. So how it works is this. Hear what I'm trying to say at this point. To solve this equation, so I want to manipulate till I get this. To solve this equation, I am just playing around with the equation here, yeah? It's the same thing as to solve the intersection of two things, this curve and this line. Makes sense, right? This is an equation equals to 0. I just shift my x over. This can be a straight line. This can be a curve. Same thing, right? I'm just playing around. But my curve is 2 sine 3x plus 1. I don't have pi sine 3x. I don't have. So I need to manipulate my way till I see this so that I can relate to my sketch, because my sketch is this. So next thing, I want the 2 to come out, right? Okay, I want the 2 to come out. So what can I do? The pi is there. I don't pi. So disgusting. I divide by pi on both sides. You realize A very close. What do I need to do? I want 2 sine 3x plus 1. Don't tell me plus 1 first. You plus 1, you multiply by 2, you get 2 sine 3x plus 2. So know your stuff well first. We need to. Very good, Clary. Thank you for facilitating. Multiply both sides by 2. Very good, Kaden. Multiply both sides by 2. And then you may realize, what, oh my god, my right hand side, the line, oh my god. Take note, it's okay. Since you guys are facilitating for me, end goal, what should I do on both sides? We are almost there. Very good, thank you, Kevin. Very good, Kaden, thank you. I plus 1. Then you may see, oh my god, what is this line? 2 over 3 pi x plus 1. But the thing is, it's a straight line, I don't care what this number is, This is like your mx plus c. It's just a straight line. So if it's just a straight line, all you need to tell yourself is this is just 2 points, or maybe if you want to play safe, 3 points to plot on the curve. So what you need to do, if you want to draw this particular line, just plot points over here, and then you are able to get the line over here as such. Okay, but here, let me see. Okay, Lionel asked a good question. Scale, yeah, Kaden just sub 1 or 0 lah. But you realize 1 or 0 for this curve a bit weird. So you must actually put in nice numbers to give you nice values to sketch the graph. Later I'll tell you. Wait, do we sketch it or draw to scale? Just sketch it is enough lah. But scaling, it depends on how you scale based on the diagram you draw. Like in this case, if this is 1, 1, 2, 3, your 1 must be contribute for lah. Cannot be your 1 here, then your negative 1 here. This one a bit too much lah. So you get what I mean. Curve ruler, if you're afraid, that's the best way to do it lah. Yeah, so back to Cadence one here. Based on the pi, correct, Clarin. Thank you for verifying. So what are we doing here? Is we want to fit in nice values. In this case, not so nice. So it's easier for us to do. So the first one, okay, maybe to get Caden. Caden, you have contributed as well. One of the values 0, easy to see. Because when x is 0, y is 1. Y I cancel out, that thing disappears when I sub 0. So x0, y1. So my first point is here. Okay, I draw a bit lah. Then you realize another point you can sub is actually based on my scale x over 2. If you type x over 2, I am going to have 2 pi over 2 plus 1. This is going to give me 2. So roughly here. Then calculate one more point to play safe when x is pi. Then we have 3. Then all you need to do, take a wonderful ruler, draw it out. I think mine is not really to scale. So I'm going to play cheat a little, but you get the idea. Okay, don't learn this. Okay, okay, just draw it roughly to scale, make sure you get a straight line. Ideally, okay, your scaling won't really affect how you draw the lines. It's more or less how many solutions they want. They will not usually ask you to find the exact value. So let me just draw my line. And all we are doing, we sketch the line down. See how many points are? So how many solutions are there? You circle how many times they intersect. 1, 2, 3. There'll be one more that people miss a lot. Here lah. Okay, so we just need to visualize the values, draw the lines, just plot random points to make it nice for solutions. Okay, can. So I'm gonna give you a while to look through this. I'm gonna zoom out. Okay, to consolidate. One thing is to note what is the value here. What points to sub in here to make things nicer for you. The other one is to know how to manipulate to get the function out. Okay, Ken, any questions? Okay, silence is consent. Very good. Or should I wait a bit more? Okay, let me drink some water. I think 1 sip of water is enough for you all to type a sentence. So I'm gonna wait a while. Okay, silence is golden. So let's move on. Silence is consent. What am I talking about? Let's move on. 2 more. Now, one more style of question they can come about is this particular style of question, whereby it's really just noting how you bring in your values to solve. I know a lot of people, when you see this, you will try to link it to the amplitude, you like it, link it to the period, and then try to solve, and then you rack your brains, and then you realize your brains are gonna burst. But I'm gonna tell you for this, there's no need. Always remember, first things before you rack your brains and you tell yourself how much your brain is gonna explode, ask yourself, before you utilize any other formulas, 2 values, right? How many equations we need? 2. To form 2 equations, how much information is enough? 2. You look at the graph. In this case, in the form of coordinates, got 2 coordinates to give? Have, right? 1091 this, just sub lor. Don't torture yourself lah. Okay, life very tough already. Okay, so first one, what we can do, all right, if you see the graph, we can plot the points first. I mean submit, sorry. When x equals to 0, y equals to 9. Let's say you submit the first one. It's fine. So I have 9 is equals to a plus 6 cosine of 0. Type your calculator, cosine 0. So somehow this equation, okay, very sweet. A is equals to 3. Good. So we have half the curve down. Then after that, you realize I have a next curve. When x is 2 pi by 3, y is 0. So all we are doing, sub it in, and then you realize A, K, 3 plus 6 cosine B of 2 pi by 3. Okay, and then you realize when I solve, oh, okay, I manipulate a little bit, cosine B 2 pi by 3. This is negative 1/2. And then you realize, I don't know what the range is. If you don't know, just assume it to be 0 to 360. One cycle. In fact, this is not even one cycle, so to play safe, one cycle to picture the whole behavior. Calculate, we know this is half, so your ASTC comes in again. This is picturing your trigo ratios. So over here, you have ASTC. Okay, we know it's an S at T, cause it's negative. So just picture your basic angle. Basic angle is equals to pi over 3. Okay, remember when we do our basic angle, we ignore the negative. Okay, so we have pi by 3. And then you realize when I solve this, there is a little catch. Why? Because if I'm solving for this angle, I have two answers. One, 2 pi by 3. The other one, 4 pi. Then you realize which one to accept. Because B is either 1 or 2. And in this case, there's only one answer. They didn't say find the values of A and of B. They didn't say find the values. Or they didn't say find the value of A and the values of B. So there's only one value we can accept. So this is where I want you all to think it through. Okay? There is a reason why they put the minimum point here. Okay? Even though you realize then some of you all may think, what is the purpose of the minimum point? Okay, now sometimes what happens, it'll be good to actually sub in the values. This is a little bit of a higher order question. Putting in the consideration, 6 plus cosine x. This is y is equals to 6 plus cosine 2x. Two possibilities, okay? And I will zoom out for you all to take note of the minimum point. Two possibilities are. Now check. Based on where the minimum point is, I give you a hint. Which one should be correct? There's only one answer for this. Give you a while to think before you type in the chat. Hey, this is the something new one over here. Give you a while to think before I type in the chat. 1 or 2? If you all don't know, toss a die in your head, then after that, I tell you the answer. Okay, I think this one, the chat a bit silent. Okay, not to worry. Let me help you out. So, what we can do, if you are not sure, you look at this question and be like, sure, wow, I look at this, I say I cannot. Go back to our fundamentals. Cosine x, what is the minimum value? Minimum value will be where x is pi, right? If I scroll up, is it possible? No, right? Not at all, right? Because the one bigger here is at 2 pi by 3. this should be the bigger value, but why is pi, which is bigger than this, at the left? It shouldn't be the case. As compared to cosine 2x, so your minimum point will actually get scaled down to the number here, which then is possible. Okay, possible. So that's why by looking at the fundamentals over here, we know this is rejected. B is equals to 2. You just need to write rejected. If you are afraid that your teacher may be affected by the working, write the final statement, B is equals to 2. A, no issues. A, only one answer. A is 3, B is 2. Alright, take some time, look at this question before I move on. Okay. How do you know the basic angle? Cosine inverse of half. You type in degrees is 60. 60 you convert to radians in your head, where pi radian equals to 180 degrees. The ending is where you take note cosine x where your minimum value is. At cosine x, your minimum value is at pi. There's some shifting, but we know it's at pi, which is not possible because pi cannot be there if my next value is 2 pi by 3. The value here should be smaller, ma. Pi is bigger. As compared to pi by 2, where it makes sense. So that's why I reject this. It's not possible. This is valid. This is my answer. I hope this is clear. Why is cosine x equals to pi? Not cosine x equals to pi. The minimum value of cosine x is at pi. It's not cosine x equals to pi, Yadabi. Because if you recall, your minimum value is always at pi for cosine x. If you draw your cosine x graph. Okay, got difference. Any other questions? Please ask, please ask, please ask. Yeah, wait for 5 more seconds before I move on. Okay, can. Now, once you get this down, I think another boring style lah. I will just really cut short through this because okay, negative 3 sine x. This is just really a recap to tell you that it is very common for you to draw the graph, and in this case, even a straight line. Negative 3 sine x. I split up for you, nice already. 0 to 2 pi, negative 3. So we need to take note. Amplitude is 3. Amplitude 3. And negative 3. I start from here. Okay, then you use your calculator and plot. Okay, sorry, I too excited to plot. I forgot to draw the lines that I advocate. Yeah, so you plot. Make sure you draw the lines here. Okay, so the lines here are just a gauge for you to draw nicer graphs. Okay, you don't have to draw them if you find them irritating. Okay, it's really for you to plot nicer graphs. But otherwise, if you do, just take the calculator, plot pi by 2 is going to be 1, negative 3 times 1 is negative 3. Then you carry on. Okay, sorry, Okay, carry on. Up and down. After that, when you draw your curve, make sure it is smooth. Flowing. Okay, sorry. This is not smooth. Okay, this is not too. Yeah, okay. Then up. And down. Okay. Then for this one, this is your negative 3 sine x. Okay, this is your negative 3 sine x. Then afterwards, for the other line, y equals to 1 minus 2x over pi. Wow, why got pi? Just now, I think one of you has shared. Let me scroll up and see the name. Sorry, la 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 la. Kevin has shared also. Based on pi, because if you do the pi divisions, you get the values easier. So, first one, of course, we love the value 0 because it makes everything disappear. So maybe here. Okay, so first one. Second one, maybe you sub in pi 1 minus 2 pi over pi, 1 minus 2, which is minus 1. So over here. Here. Then last one, 1 minus 2 pi over 2 times 2 pi, which is 4 pi over pi. 1 minus 4, which is minus 3. After that, draw a line. Whee. Okay, let me play here a little bit. Okay, so you can actually just draw. Okay, I'm gonna scale a little bit. Okay, you can actually just play cheat a little bit based on the scale. It's fine. Okay, because they just want to sketch, so it's okay. Now, find the number of solutions. You realize part 2, very similar. Okay, of course, usually when you draw a line, we draw down the equation first. So y is equals to 1 minus 2x over pi. Okay, find the number of solutions. Now, again, if you want to solve this equation, we want to relate to the question here. So we want to see a negative 3 sine x. We want to see a 1 minus 2x over pi. So all we are doing next is really manipulate. So, and then the same rationale. 2x equals to pi plus 3 pi sine 3x. What do I want? I want 1 minus 2x over pi. Okay, so maybe I want the x to be divided by pi. So I divide by pi on both sides. It's the same thing as saying 2 pi over x is 1 plus 3 sine 3x. Look at the question. They want a 3x. Yeah. Look at the question. They want. Okay, I think there's a typo in the question. Okay, do me a favor. I think there's a typo in the question. All right, sorry for that. There shouldn't be a 3 here. Okay. Yes, my mistake. All right, so there shouldn't be a 3 that. Let me change it over here. Yes. Okay, otherwise the question will take a while to solve. So sorry for that. Yeah, I'll divide by pi on both sides. Then afterwards, I want a negative 3 sine x. So this is the same thing as doing this. Then what happens? I want 1 minus. So you realize by manipulating this question, it is the same thing as this one here. Negative 3 sine x. Didn't we sketch this just now? This one over here. Didn't we sketch this just now too? So really what we are doing for find the number of solution style questions, if you were the task to draw the graph, is really relating back to the equations you have drawn. Number of solutions, one intersection. So therefore, you have English error here. Typical question, you only pick two, two of them come out like this after you draw the graph already. Okay, any questions? I'll give you a while to consolidate, type in the chat before I move on to one last one, where this one also, I would say, is quite common. Can all good? I know it's going to the end already. A lot of you are zizzing already. Can you hang in there with me, Hang in there. Yes, I think I see a query from what are the tips to study for this chapter? Okay, I answer that at the end of the class. I think that will be a good way to consolidate. I answer that at the end of the class. Easier for me to consolidate. If I answer now, I might deviate. Yeah. So remind me again if I forget, but I remember. Okay. Any other questions? Okay. Now, final style. I believe you know where this is coming. They will usually relate a viewer context question to our trigonometry. It's quite common. So for this one, usually what we need to take note of is try to see how we can link the period of the curve. Okay, because usually that's what they ask you to find, which you can read it here. This is the information. Okay, I will get you all to read it in a while. But you realize after this information, they will give you a trigonometric function. And then after that, without fail, what is B, what is K? These two are amplitude and period. Always a tip here, we always want to see how we can find the period. Easier to locate. Okay, so now looking at the question, based on the info I give you, hint here, can anybody tell me what is the period of this behavior of the water wheel? Finding K first. We usually approach by K, so it's easier. What is the period of the water wheel? Yes, one revolution is one period. Good job for identifying the keyword. I think Clarine has kindly given you the hint already as well. One revolution is one period, correct. So you see one revolution is basically saying going one round. Okay, so Clarine, maybe you want to share with everyone how much is one period for this? Since you already typed in the chat already, maybe you finish strong. Yes, that's it. Because one period is 12 seconds. So this cycle tells you if it goes one round again, come up, 12 seconds. Then now you may ask, okay lah, very good, you know one period 12 seconds. How to solve for K? Recall, we are looking for cosine. Remember the roots. What is the period of a cosine graph in terms of pi? And what is the number to be divided with? Don't write B. They purposely switch the letter because you know formula is always 2 pi over B, B, B. Then you all write B. Be careful, this is K. So that's why when you get this down, K is 2 pi over 12, which is pi by 6. This is always good to start off with first. Always find the period. Okay? Because once you find the period, actually, your next one, very easy to find already. You don't have to actually see all of this. Answer scheme actually put what? 6 plus 2 or 6 plus, 6 plus 2 divided by 2 or 6 plus 2 divided by 2 or something. Okay, because 6 over here, 2 divided by 2. But I want to tell you another way. The behavior is usually determined already with the formulas implied. So you do 6 plus 2 divided by 2, I tell you, you all will forget. We picture the scenario. Based on this sentence here. If I identify based on the behavior, initially 6 meters above the surface, in this equation, which is already half written, what does it mean? Initially, okay, based on the context here, has time passed? No, right? When t is 0, look at what the height means. Above the water surface, already tell you how much is it, So when you want to find the amplitude after you find the value here, just sub in the point. Don't use what highest value minus lowest value. You're gonna get confused. Okay, by right, it's maximum value minus minimum value divided by 2 for amplitude, which is gonna get very confusing. Don't do that. Okay, you're gonna get more confused. Okay, so let's do that. Sub in the value, you are gonna get 6. Wait Okay, I'm sliding down. Give me a moment. Okay, 6 equals to B. Cosine 0 is 1, so B plus 2. B is equals to 4. So you realize for real context, usually for Trigo, what we want to do, they will have to tell you the period in one way or the other if they ask you to find the values. Okay, I will stop here for a short while. Let me know if there are any questions. Okay, can Okay, once we are there, we realize now our graph will be weird. It's not 2 pi anymore, it's not 360 anymore. We are working with one period. In this case, it's 12 seconds. Then we realize, now not in terms of pi, how to draw? You already know one period is 12 seconds, ma? How many of a period to draw? We know our ending number is 18. So you check the scaling from 12 to 18 is how much though? Divide by 12 times 18, we know you are going to sketch 1.5 period. Same style as what we did just now, just that now that we are working with a bit of unfamiliar numbers, but not so unfamiliar if you know the period lah. Once we get this down, again, we know we are sketching 1.5 period. So good to, okay, I don't know why this cross is there. Let me just erase. Okay, split to 2. This one, because one period is 12, so I need to split it nicely over here because I know the behavior of one cycle, which is usually split into 4 parts. Before I split it even more, and then I write the numbers. So I have 3, 6, 9, 12, 15, 18, all right, in between. Okay, and then of course, I need to know what's my minimum value, maximum value. First from the center line. Center line is 2. So, okay, let me scale nicely. 2. So over here, this will be 6. And, sorry, this will be 6. And after that, I subtract by 4. So it will be this. Wait, yeah, this should be good. Yay! -2. Then one more line in the middle. Over here. Then after that, you take your calculator, plot your points if you're not sure of the shape. If you're sure, we know it will start from here, middle, down, middle, up, middle, down. If you are sure. If you are not sure, take your calculator. 0, put inside here. 4 cosine 0 is 4 times 1. 4 plus 2, 6. Then you carry on. Okay? So you just plot down. Plot down over here. Wait, okay, so here. And you do one more cycle. I mean, half a cycle. Okay, one thing to note is when you do certain graphs like this, I'm not too sure how particular your teachers are, but good to actually write the equation down. Okay, write the equation down. So it's the same stuff lah. Okay, really what we have been doing so far. Okay, just that now in real world context, we have to look up a bit more. Okay, gonna give you a while to absorb. Okay, over here. Now the last one, a similar water wheel. And then you realize, similar water wheel, okay, motion of point B modeled by the equation. Then realize, wow, what's so many water wheels? Didn't we see this style of question before? Suitable line above. What is the curve above? 4 cosine pi over t plus 2. But it give you another curve. How to relate? So determine the number of points where point B touch the water surface. We check context. What does H mean? H means above the water surface. Definition does not change. It's just I change the point A to point B. So when point B touch the water surface, this is crucial so that I can form my equation before I backtrack. Anybody want to tell me, this is a hint, if point B touches the water surface, my H here, what will the value be for me to solve this equation? Final question for the day. What is H equals to for this equation? Because for me to find, I need to make sure it will be equals to something. So 4 cosine pi by 6 plus 4. In this case, it will be equals to. Okay, just throw some numbers if you're not sure so that I know you guys are still there with me. Almost there. I know you guys are already like. Okay, Damien is giving me an answer. Thank you. Any other answers? Okay, I have a very somber dot. Okay, yeah, I've gotten it down. Awesome. All right, no height, so we know H is 0. Remember, if you want to solve and draw a line, it's like solving an equation. So thank you, Damia, Kalian, and Yadavi. Moving on, I want to get to this part. Plus 2 ma. So how to get plus 2? Okay, this one I won't ask lah. 4 cosine pi over 6t plus 2 means I subtract 2 on both sides. So what the question wants you to do is to really draw a line. H is equals to minus 2. And of course, label. And tell yourself, touch water surface means how many intersections are there. Literally, you just count 1, 2. That's it. So what am I going through for these 4 questions for today is really noting first, for graphs, draw. Second, link equation. Third, real world context. For trigo ratios, you realize the questions are quite common. Those of finding same quadrants, what's not, and asking you to find other ratios. So nothing too special. So to summarize for today, maybe to answer Lionel's question, what are the tips to study for this chapter? First, all right, know your ASTC. Okay, going for these basics, know your ASTC. Second, all right, it's really nothing much for trigo functions and ratios. Know your ASTC. For graphs, important. If you don't want to spam the calculator, know your shapes. Like sine, it's going to be up, down. Cosine, totally down to save your time. Tangent, all right, it's going to be, one cycle is going to be this way or this way. Okay, so basically what I mean is your cycle of tangent, some of you all know it as this way, or some of you all know it as this way. Both are the same. Both are the same stuff. Okay, and of course, know what your ABCs work for. Okay, know your ABCs. Basically, what I mean, example, if you were to look at A sine BX plus C, know what the ABCs function. It will work the same for cosine, it will work the same for tangent. Okay, so know these few particular parts. For this part, I'm going through know these few particular parts. Otherwise, that's about it. I don't wish to emphasize too much on the other style of questions, but basically know the basics, which is know your ASTC, know your shape of the graph, know what your ABC stand for. That's it for this chapter. All right, if not, are there any questions for today? No problem, Lionel. All right. If not, just nice. 1 minute before time's up. That's it for today. All right. So before you all go, what happens? All right. If you are interested in this flow of the stuff, in flow of the exams, or flow of this revision, all right. Do feel free to scan and look at the slots that are available if you are interested. I do teach Sec 4 A Math and Sec 4 E Math at my site at Bukit Timah. 5 to 7 for AMath, which is this one, and maybe advertising as well. If you do not have, I would say if you're not available at this time slot, there are other capable AMath teachers as well that allows the teaching to flow through as well. Okay, yes. Okay, no problem. Kevin, just give me a moment. Yeah, you want both the empty copy as well and the written copy? Empty. Okay, give me a moment. I will send it in a while. Okay. Yes. So back to the chat. All right. If you are interested, all right, feel free to scan. And look out for the timings over here, lah. Okay. So for me, I'm teaching Sec for A Math at 5 to 7 at Bukit Timah. If the slot is not available, we do have capable teachers as well, like Teacher Clemens, who is taking you for the Trigo 2 tomorrow for those who are going, and Teacher Qian Wei as well. Uh, he mainly teaches at the east. So for those Easters, Eastsiders, that's the best slot for you. And yeah, mainly where are my names? Never mind. Yeah, somewhere here. So all the AMF slots, you can look at the names if you are interested lah. Okay. Otherwise, if you have enjoyed this session, do me a favor. All right, scan this over here to drop a review. I'll be more than happy to actually receive them, and it's quite heartening to actually know that you have benefited from this. Okay, no force. If not, thank you for your time. I will be hopeful to see you guys soon. All right. And yeah, that's it for today. Let me stop the recording right now.